Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about chapter matter. In this session, let us see the physical classification of matter. That is the classification of matter into five states. There are solids, liquids, gases, plasma, and BoseEinstein Condensate. Actually, the whole universe is composed of only two things. They are matter and energy. These two only are there in the whole universe. There is one more third one also, that is nothing but a empty space or vacuum it is called. Other than that, only two things are there in the whole universe. Those two are matter and energy. So here the chemistry is a branch of science which deals with the study of composition, structure and properties of matter and the various changes it undergoes. So, among these two, between these two, matter and energy, about matter we study in chemistry branch of science. So, chemistry deals with the composition, structure, properties, and various changes this matter undergoes. These all are studied under chemistry branch. And one more in that university is energy. About energy we study in the physics. So different forms of energy like light, heat, sound, magnetism, electricity. About this all we are going to study in the physics. Now here in chemistry especially we study about matter and its properties, composition and these all. So what is matter actually? Matter is anything that has a mass and occupies a space and can be perceived by our senses. So senses like we can touch it often, we can smell it, we can weigh it. So in this way, anything in the universe, whatever it might be, if it is having some mass and occupying some space, and if it is perceived by our senses, then it is said to be a matter. Matter exists in many forms. See here, some examples are shown. The water present in this glass is a matter. This glass itself, it is a matter because it has some mass and occupies some space and it can be perceived by our sense. We can touch it. So it is a matter. These ice cubes comes under matter and this kettle is a matter. And the vapors coming out from this kettle also come under matter. These ice cubes, stones, gold, air, these all are different forms of matter only. As we look at our surroundings, we see a large variety of things with the different shapes, sizes, and textures. See here, different examples for the matter are shown. These all will come under matter only, but they are seen differently. They will be having different sizes, different textures, different materials made with they are made up of. Even though they are come under all together under matter. Everything in the universe is made up of materials which scientists have named as matter. So these all are made up of matter only. The air we breathe, the food we eat, stones, clouds, stars, plants and animals, even a small drop of water or a particle of sand, each thing will come under matter. These all are matters only. What are the characteristics of this matter? Matter is made up of tiny particles called molecules. The molecules in turn are made up of small particles called atoms. So every matter is made up of certain molecules. These molecules are made up of atoms. So atoms are the fundamental particles of every matter we can say. Because we're telling matter is made up of molecules. These molecules are made up of atoms. So atoms are the smallest particles of every matter. Atoms are the building blocks of matter we can say. Okay. The molecules are so small that they are not visible to our naked eye. So actually we are telling every matter is made up of molecules. For example, if you take a small chalk piece, it is a matter because how do you say as it is matter? It will be having some mass and it occupies some space. So and it can perceive our sense. So it is a matter. Now, if you say, if you break into small piece, it becomes two. If you still break it, it becomes a small piece. If we continue like that, breaking it into small pieces, at certain time, we get a smallest piece of that chalk piece, which we cannot cut with our physical means. The smallest particle of that matter is called its molecule. These molecules actually we cannot see through the naked eye because they will be very, very smaller. Molecules of matter are constant vibration. Yes, molecules of every matter will be in constant vibrations. All material bodies have mass and have hence weight also. Yes, all the matter will be having some mass, so they'll be possessing weight also. All materials occupy space. In different states of matter, the arrangement of molecules is different. Yes, we're telling every matter or material is made up of molecules. So, in every matter, there will be molecules. So, based upon the arrangement of these molecules, the state of matter will be differed. So, based upon this, we can classify the matter into different states. That we can say physical classification of matter. As there are so many kinds of matter, a scientific study of matter becomes easier if we classify matter based on some characteristics. Yes, we are telling everything in this universe which is having some mass and occupying some space and perceived by our senses is coming under matter. So, as there are so many kinds of matter, if we classify them scientifically, so that the study of these become very easier. So, matter is classified based on some characteristics to make the study of this matter easier. So, matter can be classified based on two factors majorly. One of them is a physical classification, nothing but the classification of matter based upon the arrangement of molecules in the matter. We're telling every matter is composed of molecules. So, the arrangement of molecules won't be same in all kinds of matter. So based upon the arrangement of these molecules, the state of matter is going to be changed. That we say as physical classification of matter. One more it is there, that is chemical classification. This represents the chemical composition of matter. What kind of substances are present inside the matter? Based upon this, matter is classified in this chemical classification. Okay, these are the two major factors on which basis we can classify the matter. So this is the overall chart which representing the classification of matter on two major factors. One it is physical classification and chemical classification. If you see, based upon physical classification, matter is classified into five states. They are solids, liquids, gases, plasma, and Bose-Einstein Condensate. Out of these five, these three are very well known to us, very familiar, mostly seen. These two are rarely existing. We are going to see about those also. Okay, this is a physical classification. This is based upon the type of particles existing in the matter and their arrangement. One more classification, chemical classification, based upon the chemical substances present in the matter, based upon the purity, what kind of particles are present in the matter. This chemical classification is done. If all are same kind of particles in a matter, then that matter or that substance is called pure substance. If it contains more than one kind of particles in it, then it is called a mixture. So this chemical classification we are going to see further. First, let us see about this physical classification of matter based upon the arrangement of molecules into five states. Okay, and the two out of these five states, these three are very familiar to us. Let us see first about these three. Matter is composed of extremely small particles which are called molecules. Based on the arrangement of these molecules or particles, matter is mainly divided into three types. What are those three we told? Solids, liquids, and gases. Yes, these three are the major states of matter. Mostly we see in our surroundings, in everything. For example, they have given here ice, which is a solid, and a liquid, water vapor in the gaseous form. So these three representing three states of matter. First, let us say about solids here. In solids, the molecules are closely packed. Suppose if we consider this as a matter, see how molecules are arranged. They are arranged very closely packed. Their positions are almost fixed. Actually, we told molecules are in continuous vibrations in every matter. But in case of solids, molecules as they are tightly packed, these vibrations will be very less. There will be, but they're less. That's why solids retain their shape and they have a fixed volume also. So, as molecules are tightly bound one to another, they cannot be separated. So, their shape is fixed and even volume also. The force of attraction between molecules, which is known as intermolecular force, exercises a greater influence in solids. However, the space between the molecules is very small in case of solids. Example for the solids you see here: ice, a brick, a piece of chalk, a metallic pot, and these they do not change their shape, even the volume also. So these all come under examples for these solids. They will be having fixed shape and volume because in those matter molecules are tightly bound. Now let us see here the generalized properties of solids. Solids have fixed shape and fixed volume. Generally, solids cannot be compressed. We cannot compress them because in that already molecules are tightly packed one to another. So there are no gaps between them to compress them. So solids cannot be compressed. A solid does not flow. It cannot move itself until and unless we apply pressure on it, it won't move. Okay, they cannot be moved, they cannot flow. A solid expands very little on being heated. Yes, solids on strongly heating, they expand a little. Solids have very less interparticle spaces and very high interparticle attraction. Interparticle spaces. This means the space between the adjacent particles or adjacent molecules in the solid. That space between the particles or molecules in solids are called interparticle spaces. These are very less in solids because molecules are very tightly closed one to another. Whereas as they are being very close to each other, the attractions are much high. Those are called interparticle attractions or intermolecular forces. These are high in solids. That we can say simply the friendship between the molecules. The friendship between the molecules is very high in case of solids. That is why they'll be always close one to another. Okay, these are the properties of solids. Next, let us see about liquids. In liquids, the molecules are not packed as closely as in solids. Of course, here also there are some attractions, but not much that as in solids. Liquids, therefore, change their shape easily, but not their volume on their own. Okay, the molecules are packed here also, but not that much closely as in solids. That is why these liquids can change their shape according to the container in which they are kept, but they cannot change their volume. So the volume of liquids is fixed, but their shape is not fixed. They do not have definite shape. The intermolecular space, that is the distance between the molecules in a liquid, is more than that in solids, and hence the force of attraction between the molecules is weaker when compared to solids. Okay, as we are telling, molecules are loosely packed, then the distance between the molecules will be somewhat greater when compared to solids. whereas the attraction between the molecules will be smaller or weaker when compared to solids. That's why a liquid does not possess a definite shape and takes the shape of container. Yes, whatever the container in which this liquid is kept, that liquid also will acquire the shape of that container. But the volume won't be changed wherever you keep this liquid. Volume is fixed, but they do not have definite shape. Examples for the liquids you see water, milk, alcohol, tea, some fruit juices, oils. These all will come under examples for the liquids. These will be having fixed shape but no fixed volume but no shape. Okay. Now let us see generalized properties of these liquids. Liquid has no fixed shape. It takes the shape of the container. A liquid can be compressed only to a small extent. Even just like the solids, even liquids also can be compressed to a little extent. But solids cannot be compressed much, as we know. Liquids can be compressed to a little extent. Liquids can flow because between the molecules the attraction is not much as in solids. They are loosely packed a little. That's why molecules can slide one another and hence liquids can flow. A liquid expands or contracts more than a solid. We told on strong heating, solids expand a little, but liquids can expand a little more than that of solids. Liquids have more interparticle spaces and less interparticle attractions compared to solids, as the molecules are loosely packed, whereas the molecules in solids are tightly packed. There, the attractions are much greater in solids, whereas in liquids, molecular attractions are somewhat less when compared to solids. Next, the third state of matter, that is gases. In gases, the molecules are at a greater distance from one to another as compared to solids and liquids. So here, they are free to move. Gases have, therefore, neither a fixed shape nor a fixed volume. So we can say here there are no attractions between the gas molecules. They are free to move. And the distances between the molecules are very high when compared to that of in solids and liquids. That is why gases do not have fixed shape as well as fixed volume also. In a gas, the molecules move very fast. The interacting forces or interparticle forces between the molecules are very weak, and molecules enjoy full freedom of movement. They can move as they want in any direction. But in the liquids, they cannot move as they like. Okay? In gases, the molecules are having full freedom of moving in any direction. And because they do not have attractions between the molecules. See here how the molecules are moving in all the directions in gases. Hence, a gas neither have a definite volume nor a definite shape. Okay. Example for the gases, what can we say? So many gases are there in the air. The air in the atmosphere is a mixture of several gases like oxygen, nitrogen, carbon dioxide, water vapor. This all will come under different examples for the gases. The generalized properties of gases also, let us see here. A gas has neither a fixed volume nor a fixed shape. It assumes the volume and the shape of the container in which they are stored. Because between the molecules of gases, there are no attractions. They can move in all the directions randomly. That is why these gases do not have fixed volume as well as fixed shape. The shape of the container itself will be taken as the shape of the gas present in it. The gases can be compressed to a much larger extent than solids and liquids. Yes, solids cannot be compressed at all, and liquids can be compressed to a little extent, but gases can be compressed to a large extent, because in gases molecules are very free to move. They are very loosely packed. Between the gas molecules, spaces are much higher, so they can be brought together with high compression. So gases can be compressed to a large extent. Very fine example for this, the gas cylinders which we are using in our homes for cooking. I observed those that contains a gas which can be used for nearly 1 month or 2 months cooking. That much of gas is stored in the cylinder, the small cylinder itself. How it is done? By compressing the gas. A large amount of gas can be compressed and stored in a small cylinder. Okay? A gas expands to a greater extent on being heated. Okay, so how we told as compression, this expansion also much higher for the gases when compared to solids and liquids. Gases freely mix with one another. This is a special property of gases. The intermixing of gases is called diffusion. This diffusion property is special for gases. It is not there for liquids as well as solids. The intermixing property, they freely mix with one another. That's called diffusion. Gases have very large interparticle spaces and negligible interparticle attractions. As particles of gases or molecules of gases are very far away from one to another, the particle distances are much higher, and attractions are very less, or simply we can say they are negligible when compared to the attractions between the in the case of solids and liquids. Okay, next, the fourth state of matter, that is called plasma state. Plasma is the fourth state of matter. Plasma is similar to the gaseous state. Plasma is made by heating a gas. We know when we heat a solid, it converts into liquid, isn't it? When we heat a liquid, it converts into gaseous form. We know that. So when you heat a gas, what happens? This is what the fourth state of matter will be formed. When we heat gases at very high temperatures, we get this plasma state. So plasma is made by heating a gas. So if you heat a gas to very high temperature, then atoms and molecules in the gas lose all the electrons, and ions and electrons, they exist in the, say, in the phase. What happens when you heat a gas? The molecules and atoms, whatever are there in the gas, they lose the electrons. Then these ions and electrons coexist at a temperature. That state is called plasma state. So see here, one of familiar example for us where plasma is existing is sun. The plasma is produced in the sun and stars is because of very high temperature. So there in sun and stars there will be very high temperature. It will produce at continuously very high temperature. Because of this high temperature, the gases present in the sun and star, they are completely ionized. What's the meaning of ionization? The molecules and atoms present in those gases, they lose their electrons completely. Then they form ions and electrons to coexist. That is why this plasma is created in them. The sun and the stars glow because of the presence of this plasma in them. Okay, we say sun and the stars are being glown. This is because of the presence of this plasma in them. Did you understand how plasma is formed in the stars, sun and stars? As they're existing very high temperature in them, the gases present in these stars and sun, they ionize. Means the atoms and molecules in the gases, they are lost by the atoms. They lose their electrons completely. Then these ions and electrons coexist in them. That state itself it is called plasma state. Because of the presence of these electrons and ions, they are being glown. That means they are glowing because of the plasma state. Okay. On the earth, not only in the stars and sun, on the earth also plasma is naturally occurring in some flames, even in the lightning also, and even in the northern and the southern lights. Often we observe some lightning in the north and south polar regions. So that is because of the plasma existence in the nature. So even while lightning also, because high voltage produced in the sky, the air present nearby that will be ionized for a fraction of seconds, that glows because of the plasma formation. Okay, in this way, on the earth also plasma occurs. And next, the fifth state of matter, that is Bose-Einstein Condensate, which is simply called BEC. In 1924, Albert Einstein and Satyendranath Bose predicted the Bose-Einstein Condensate, simply BEC, which is referred to as fifth state of matter. How it forms? We told just now, when we heat a solid, it converts into liquid form. If we heat a liquid, it converts into gaseous form. If we heat a gas at very high temperatures, it converts into plasma. Now, this Bose-Einstein condensate is formed by cooling a gas to very, very low temperatures. The, clearly to say, in the reverse way, how plasma is formed, to that reverse way. When you cool a gas to very low temperatures, that too nearly to the absolute zero temperature, then this Bose-Einstein condensate is formed. So a Bose-Einstein condensate is a gaseous superfluid phase formed by atoms cooled to temperature very near to absolute zero. So a Bose-Einstein condensate is a state of matter of a dilute gas of bosons cooled to temperature very close to absolute zero. What is absolute zero here? It is a temperature which is equal to 0 kelvins, or minus 273 degrees Celsius temperature. This temperature is called absolute zero. When you cool a gas to this temperature nearly, then the vibrations of the molecules almost will be freezed. They won't move at all. The volume of the gas becomes almost zero. That state is called Bose-Einstein condensate, or BEC. So under such conditions, a large fraction of atoms or molecules collapse into the lowest quantum state, producing a superfluid which we call as BEC. Okay, in this way, Bose-Einstein is formed when we cool a gas to very, very low temperatures, that is nearly to 0 kelvins or minus 273 degrees Celsius temperature. At the temperature, the gas converts into BEC. Okay, these are the 5 states of matter. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today and visit our website www.aimstoday.in for latest updates and recorded videos. Thank you.